Hi grade 10s, this is Mr. Zhang. I'm at home, not feeling the greatest, but my back is still hurting me. But I want to get this video out so that you have something to learn for today. So one thing that I want to point out is last class, I overheard some people saying they didn't have enough time to finish. They're still not quite sure what is going on with the code that you're writing. And I really want to emphasize that this is high school, which means that it's your responsibility to catch up. We do have tutorial times. We do have that time built in so that you can ask your teacher questions, as well as, once again, on Google Classroom, all lecture files, unless there is some catastrophic failure with the recording, are uploaded to Google Classroom. Therefore, even if you've missed a day, right, it's not my job to catch you up. It is your job to catch yourself up. And whether that means you come during tutorial time and watch the videos, or that you download the trial version of App Game Kit and install it at home and work through the videos at home. But at the end of the day, you have the resources to catch yourself up, and if you're still confused after putting in some effort, then you can definitely come during tutorials and ask more specific questions. However, it is important that you take responsibility for your own education, because it only affects you. I'm already done high school. It doesn't matter to me. It matters that you finish high school and that you succeed and you pass, and it's not my job to do it. It is your job. So with that out of the way, I just want to go back to our code from yesterday, where you are required to create 2 boxes, and one box was supposed to bounce across all the screens, and then the other box is supposed to move by WASD. So if I go to our scene, it looks like this. Then we have our code, and today we're going to go through boundaries with WASD, collisions, and loading an image, hopefully, kind of see how much time we have. But this particular code is an example of what it should have looked like. So when I hit run, then we should get a box moving and bouncing, and that's all that's anticipated. And then also, if I click WASD, then I should have my box move as anticipated as well. One thing that we haven't actually coded in yet, so I want to get it in today, is that my moving box can actually go off screen, and that's generally not a good thing with our coding boxes. So we want to start by creating boundaries for our box. So with that, the other thing that I'll probably note is I may choose to upload a PDF of this code, so that if you do need to write it all down because you're still having difficulties, then feel free to type it all in. Once again, I'm going to try to set it so that you can't actually copy and paste, because it's important that you type so that you are used to the commands. And apart from that, also, like, if you're still having difficulties with what the commands mean, how they string sequentially from one to other, you really need to come ask for extra help before the exam, or else you're going to do poorly on this unit, and you do need to pass this unit to continue on to Computing Science 20. So with that being said, I've changed my resolutions to 640 by 480, just so it's easier to see on my screen. And then we created the red and blue sprites, and then the red and blue sprites. And here, one of the things I added in immediately was to put a red X and a red Y, and a blue X and a blue Y. And also here in comment, in case you're wondering, this is where you get the X and Y coordinates to move randomly. Now, I'm not going to go through it today, but it is there if you are interested. And then there is the variables for the directions of X and Y, as well as I did a variable for my blue speed, just so that if I change the speed of my WASD, I just need to change it in one place instead of changing it in every single place. So with that, we'll go into our do loop, where we have a section for the red box and a section for the blue box. And to start with the red box, one thing that I noticed was a lot of students were forgetting the set sprite position at the bottom. So in our Hello World 2, we had set text position, and we just need to make sure that we actually update our position, because this was a hiccup with quite a few of you. So hopefully you don't forget that next time. We have our 2 equations, one to move our X, and then the other to move our Y. And then we also had our bouncing, so bouncing off the right, bouncing off the left, bouncing off the bottom, bouncing off the top. So that is pretty standard for our red box. Then we move to our blue box. So this is the one where we had to include our WASD, so ADWS, with all of the movements, and then set sprite position. This is where we want to add the new stuff, where we are also putting in a boundary. So when we think about what is going on, so this is going to be adding boundaries to moving box. So when I run this, what I want to see is that when my blue box gets all the way to the right side, it doesn't go off screen like this, it stops. That's really important. And same thing on the other side is that it stops. So instead of worrying about a direction, what I want to worry about is that if the X position is ever on the left side right here, well, then I want it to reset to inside of my box. So to start off with that, we can go ahead and say that if blue X is less than 0, right, because of the fact that this is our 0 X coordinate, right, then we can say if it's less than 0, we want blue X to equal 0. And then it won't go off the screen. So now that I have that, if I run this and then move to the left side, even though my key is still pressed down, you can hear me clicking, it still doesn't go to pass because the value of blue X becomes less than 0, and then it gets reset to 0. So then it doesn't actually move. One important thing to note though is that it does matter where we are placing these, because if I do place this after set sprite position and I do this again, what we'll see is actually I go a little off screen. So hopefully you can see that, where you can see it's moving a little bit off screen because it's setting the sprite position before it's doing the test to reset it appropriately. So for one frame, it does actually go off screen. So it is important to make sure that we are putting our set sprite positions at the very bottom so that it is done after all of the tests occur. So I have one for our left side. This is our easier side. We also want one for the right side of our screen, which is harder because we have to now think of our window properties again. So we have this right side, but this right side is just our get virtual width, but we got to also subtract the width of our box. So I can then go ahead and in here, I'll just make an else. If blue X is greater than get virtual width minus get sprite width of sprite, this is sprite 2, then I want it to set it so that it is at that very edge. So blue X is equal to get virtual width minus get sprite width of 2. So now with this addition, and with spelling correct, and also with making sure that I have the correct end ifs, then when this runs, when I go all the way to the right side, it'll go and stop, and then when I go all the way to the left side, it'll go and stop. So then from here, then I can take what is here to add bounds to move box. So this is our left and right boundaries, window boundaries. There is also a top and bottom window boundaries that you can figure out yourself, which will of course use our blue Y and then our get virtual heights and our get text heights instead. So that is us adding boundaries to our WASD movement for a sprite as well. So then from there, now we can go ahead and work on collisions. So how do we go about and do collisions? This is actually probably a good time before we hit collisions, maybe to pause the video right here for about 10-15 minutes so that everyone can get their boundaries working. And because I'm not there, as a reminder, help each other out. If someone at your table gets it, and then be the expert of your table and help those that don't get it so that no one gets left behind. So please make sure that you are helping each other out in order to make sure everyone understands what's going on. So go ahead and pause the video, and then in about 10 minutes, start it again, and then we'll go on from here. So now I can imagine that you've paused the video for 10 minutes. So we're going to go ahead and get started with the next section, which is to deal with collisions. So I've not actually filled in the boundaries because I don't actually pause for 10 minutes when I'm pausing, but hopefully you're able to fill in the top and bottom as well during this time. So from here, the very last section that we want to get into is we have red box, we have blue box. Our last thing that we want to do is we want to test for collision. So when we test for collision, we have to make sure that we do this after both the sprite positions are updated. So we have a set sprite position for blue, we have a set sprite position for red, so both of them are fully up to date. And then we can go ahead and say if get sprite collision of sprite 1 and sprite 2. So if this equals 1, we can do something. So something that we can do just to really drill home what happens is that we want to make it move. So what I'm going to go ahead and do is I'm going to say that for my red x, this will equal 0, my red y, this will equal 0. And then to keep things simple, I'm also going to go my blue x is equal to get virtual, this should be equals, get virtual width minus get sprite width of 2. And then a blue y is going to equal get virtual height minus get sprite height. So hopefully with these two commands, you recognize that I'm putting red in the top left corner and then blue on the bottom right corner. And of course it's flipped, so it looks like this. So red and then blue. So hopefully that's what comes up. I just need to set sprite positions for both. So 1, red x, red y. And then set sprite position 2, blue x, blue y. And I realize that's low on the screen, so I'm just going to move up. And then, of course, once we're done, we want to end our if statement for our sprite collision. So now that we have this new section added, as long as all other sections for the most part are working, then when I go ahead and hit run, if these two boxes collide, they will reset their positions to the given positions and then continue on their merry way. So see that they're still moving, and then when they collide, they reset. So oftentimes we don't want them to necessarily reset, we want them to do something else. So say, for example, if I'm firing a laser at an enemy, I want the laser to disappear and the enemy to disappear. So that could be a solution. Or I get two that collide, maybe they fuse and they form something new. That could be something as well. So there's multiple things I can do, but for the most part, at least they can start by colliding and then moving positions, and then at least that gives us a starting point. So with that, that is collisions. It is this set of lines. So once again, you may want to pause the video here just so that everyone has gotten this, gotten it working. It should hopefully be 5 to 10 minutes, but also just adjust to whether or not students need more time or not. Okay, so when it comes to this collision, we always just want to be aware that the collision does test between two sprites. So if ever we need to test more than two sprites, we always have to do one sprite and then another sprite. So say, for example, if one was a player sprite, 2 was an enemy sprite, well, then we go like test if get sprite 1 and 2, 1 and 3 if 3 is another enemy sprite, 1 and 4 if it's another enemy sprite, and so on and so forth. So it only does do 2 of them. There are ways to get it to test more, but we won't worry about that for now. So that is the collision section. And then finally, the very last thing is going to be loading an image. So in Classroom, there should be this post already posted, hopefully, which has a ghostsprite.png. The reason why we use this one is because a PNG has a transparent background, whereas JPEGs and other file formats often don't. So if you don't want like a white square around your image, you do want to find a PNG with transparency in order to make sure that there is no white square. Of course, if you're taking applied graphic arts or photography, you may have already learned some techniques in order to remove that background, and you can also apply that to your images as well. So what we want to do is we want to go ahead and download this image. It's going to go into your downloads folder, but what's important is that we actually don't want it to stay in our downloads folder. We need to make sure AppGameKit can find this particular file. So if I go to Reborg for a moment, let me just full screen this. Like when you download this particular file, this will go towards your downloads folder. But what we actually want to do is we want it to download somewhere else. So if I go ahead and right click or click on the image and then right click on the image, come on, save image as, right? It will tell me by default to save it in my downloads. But where I really want to save it is actually in the project folder of the project I'm in. So I'm going to go back to Pi and I'm going to go into Documents. And in here, there's our App Game Kit projects. And there's boxes, which is what we're in right now. When you've run your program for the first time, App Game Kit makes this media folder. And in this media folder is where you go ahead and place your media. So I've already put the Ghost Sprite in here, but you need to make sure that you download and save it to the media file of the projects that you're in order to make sure that it works. Other things to note is that App Game Kit does have maximums and dimensions. So if your image is much too big, then you may have problems with it. And if it's much too small, then you may not see it very well, but we'll talk about scaling later. But if it is too big of a file size, it just won't load. So this is 4 kilobytes. That's a pretty small file size, but if you're using something you take a camera off of a mirrorless or DSLR and it's like 20 megabytes in size, it's just not going to load because it's too big. So with that being said, with that particular file in, how do we go about and incorporate it into our program? So we're going to do it here in boxes, but realistically tomorrow, I also want you to do it in its own program. We'll call it Spooky because it's close to Halloween. But what we want to do is we want to just load an image in here and change one of our sprites to that image. So how we go about and do that is we still have our create image colors right below this. This is where I'm going to go ahead and put load image. So I want to put it near my colors because my colors and my image will share the same integer number values. So when I go ahead and load image, when I choose an integer value, I can't choose 1 because 1 is already being used for our red image color. So I have to continue onwards with 3 in order to get the right color. And then from here, I can go ahead and put the name of the actual file. So the name was ghost_sprite.png. I need to have the file type in there in order for it to work. So load image 3, ghost sprite png. So now that's here, I can go ahead and change my sprite from using image 1 to image 3. And now when I go ahead and load this, it will hopefully now load. It's doing it off screen, so let me move it around. It will now load the ghost sprite in my actual program. So because of the fact that there's transparency, we have a black background, we don't have a white box. We do have an outline because obviously we wouldn't see the black ghost without that outline, but that's built into the picture itself. So you can definitely try that as well, but realistically today is predominantly a catch-up day so that you can get to boundaries with WASD and collisions. If you don't get to load an image, that's fine because we'll end up covering more of that tomorrow anyways. But for today, just make sure that you get boundaries for WASD and collisions all up and loaded so that you're able to move on to the next thing, next class. But apart from that, that's everything from me today. Once again, please help each other so that no one is really left behind. Please don't be afraid to ask people for help. Hopefully maybe our sub can has some computing science background, we'll see. But it is important that you help each other out in order to make sure that everyone finds success. Apart from that, that's everything for me. Please stay on task. You can definitely listen to music still, but please make sure that your side chatter is not overpowering your work time. Because once again, this time is for you to work, not time for you to socialize. So please use that time appropriately. Apart from that, that's everything from me. And I'll hopefully see you tomorrow when my back is feeling better. If it's not, then maybe you'll see virtual me again. But apart from that, I'll see you next time. Bye.